Hello everyone, I'm happy to welcome you all. My name is Vlad Bagnuk, I'm a Community Marketing Manager at Developer Shore. Join our community of great developers to follow our job opportunities, activities and future webinars. Interested? Just respond to the webinar invite email or fill out the form on our webpage developershore.com. A recording of this webinar will be published on our LinkedIn page. And now, welcome the speaker of our webinar.
Hello everyone, I'm Péter Földházi Jr. and I'm very happy to be here during this morning in Central US time and afternoon or early evening more to the east. And thank you very much for all who joined and also who will listen to this recording later on. And yeah, let me actually share my screen. Probably that will help. Just a moment. And all right. So as I mentioned, I'm Péter Földházi Jr. and I'm working for EPAM Systems, and I've been with the company for almost 10.5 years. So I think quite a long time now. And I still remember the first day when I walked into the office. And so I started my testing career back with Dota, so testing games, and then in the Hungarian telecom. But EPAM is where I really spent most of my test time, and mostly as a test automation engineer. Quite more recently, like in the last 2.5 years, as a quality architect and basically a test automation consultant. And the topic I'm bringing today is the flow model pattern and comparing it to the page object pattern, because there's a historical sense behind it. But I will give some more insights to that a little bit later. All right, so because the flow model and also the page object patterns are basically design patterns, it's very important that I speak about that. After that, I will, of course, talk about the page object pattern, which is currently the most widely known and most popular design pattern for test automation engineers. And I'd like to show you an alternative in the flow model pattern and how it could be used not just in UI test automation. Okay, I hope the agenda sounds great, and I hope that you're going to enjoy learning something new or like revisiting some topics as well. Okay, so let's get it started. So first one is the design patterns, and when people talk about the design patterns, most engineers think about the original Gang of Four design patterns, which were defined at the beginning of the 90s. There are 23 of them, and creational, structural, and behavioral patterns. And I think as test automation is partially development work, partially testing work as well, I think it's important for us to at least be aware about the design patterns and know some of them by names, and also what and how you can use them in your test automation life. And for me, my favorite one, and I'm just going to show one of them. So my favorite is the Facade Pattern, and the reason why I'm sharing it is not just because this is my favorite design pattern, but also because this is leveraged in all of the test automation specific design patterns, the page object and the flow model as well. So basically, it provides a simplified interface to your code, and it makes sure that if you want to reuse certain lines of code, you can easily do so, and you don't really have to worry about the details behind those code. You just want to use those services. Just like in this example, which is kind of already a spoiler to the flow model pattern. So you have a facade inside the pages, and the flow models here, for example, this login flow is going to leverage those facets. So this is going to make a call to those methods, but how they are implemented is not really a concern of the login flow, just like how those different steps and user flows are being implemented is not the concern of the test scripts. They just want to leverage those steps and user flows. But more to that a little bit later. Okay, so I mentioned that there are a couple of test automation design patterns, and all of them are basically leveraging the facade pattern. The first one was the page object, and it was basically being used since the beginning of the 2000s, so at least 2 decades now. The screenplay pattern was invented a couple of years later, and it's also widely known and used. And the flow model pattern is something that I came up with almost 10 years ago, because it was at the beginning of 2013. And my colleague, like he used to be an EPMer as well, Roman Yevlev, he came up with the UI objects, which is more focused on how you operate your pages. Okay, let me just make some changes in my Zoom because I'm not seeing the screen completely. All right. Okay, so the page object is mostly focused on the pages. Screenplay is mostly focused on the users, but not just the users, but there's a user aspect to it as well, how you organize the users. The flow model is focused on the user actions, and the UI objects, as I mentioned, it focuses on operating the pages. Okay, so more to the history of the page object. So as I mentioned, it was the idea really was born at the beginning of 2000s. And actually, even before that, at that company, at Fort Works, they were already leveraging the window pattern that came from Martin Fowler. So probably that's a name that hopefully many of you recognize. And that was basically the base idea for the whole WebDriver, and then that's how also the page object was born, and the WebDriver was eventually the basis of Selenium. So again, something that hopefully many of you already have heard about or even use. And so it was first publicly shared in 2007 by Simon Stewart. Okay, so the flow model, as I mentioned, I first started leveraging it in 2013. There was a project and where I first had to provide an IS test automation solution. And I created page objects and they were nice, but I realized that actually I could get away without having the page objects there because of how I was able to organize my test cases and my steps, and being able to interact with the elements through certain IDs. And so I felt that I still needed something to really organize my test automation solution, more like the test libraries that were specific to that application. And it was more of the steps that I wanted to reuse. And that's how the flow model was born. Later on an Android project, I decided to bring back the page models, and I realized that I could actually leverage the two at the same time. Okay, there are some examples on GitHub that you can find here, and a more detailed article on my website. Not everything is mentioned there, so it's definitely worth waiting till the end of this presentation, because there will be some more information. Okay, so the page object pattern, let me give you some examples first. So there's this test case. If you take a look at it, are you going to immediately recognize what this test is? Give it a couple of seconds and try to understand what this code is about. So probably you recognize that this has something to do with login. You see that I'm trying to log in with my account Darth Vader and my password, I am your father, and I'm waiting for the home screen to log in, to appear. So that means that this is supposedly a successful scenario, and then I make some assertions, and then I log out. That's it. So it's just a simple login, log out, a successful one. And so it's compared to that, it's quite a long script, and it's a little bit more difficult to realize in the first couple of seconds what it does. And think about, like, you have 1,000 test cases. Like if you spend 10 seconds on, or even more, like 20 seconds on each of those test cases to recognize what they are doing exactly, what are the exact steps, with just 1,000 test cases, that's 10,000 or 20,000 seconds. It's quite a lot of time. So being able to do some refactoring or any changes, or if you are a project newcomer, probably that's going to be a little bit difficult time for you at the beginning, in the first couple of weeks or months. And so, yeah, that's how my face looks like. If I'm still seeing anybody trying to create a serious test automation project following this linear scripting approach. And that's why the page object model was invented back in the days, because they realized for works that, hey, actually, there are elements on the pages that can be, that they are interacting with a couple of times, not just once, but maybe 5, 10, or 1,000 times. So it makes sense to store those elements in class files, and whatever changes happen to how you locate those elements, those changes have to be made in only at that one point, instead of in, let's say, 1,000 test cases. So obviously this is a more more object-oriented approach, and saves a lot of time. And this is all focused on the pages. So each of the pages that you're going to interact with should have a class file, a model, a page model, and each of the elements that you're going to interact with should be stored in these page models. Those that you're not going to interact with should not be. But more to that later. Okay, and so there are a bunch of people who said that the page object model is flawed, and there are some principles that are broken. I myself, I don't agree with all of those remarks, but there's one thing that I agree with, and that relates to the solid principles, which are actually, again, pretty useful for test automation engineers as well, not just application or system developers. And so I'm going to go into details with the single responsibility first. So in this example, you can see a bunch of shapes on the left side and the same shapes on the right side. So the reason why I organized it this way is because this one on the left side represents one class file with these three different shapes. On the right side, these three shapes are separated into three different class files. So I guess you already see what I want to represent with this, is that basically, if there are multiple responsibilities for a class file, it makes sense to separate those responsibilities and have them in separate multiple different class files. Very simple class files with a single responsibility. The reason for that is, and again, this is a very simplified example. So the reason why it's necessary is because, let's say I want to make a change in the circle. So if I want to make a change in the circle, I'm making a change in this class file on the left side. What happens is this might have an effect on all the other logic as well that's stored inside that class file, depending on how I implemented it and how well I know that class file, and whether I'm making something that I shouldn't be doing. And it might affect the triangle and the rectangular as well. And I don't want to do that. If I only want to make a change in the circle, I don't want to affect the other shapes. So that's why it's better to separate them, because whenever I'm making a change in the circle here, I'm never going to affect the other two shapes. Okay, now again, I understand this is a very simple example, and there are classifiers that have over 1,000 or 10,000 lines. Like think about the Android view. I don't know how long it is now, but about 8 years or 9 years ago, I think it was around 13 or 17,000 lines of code. So that was pretty long. Definitely not adhering to the single responsibility. Anyway, so if you think about that, there are like in your projects, like what classifiers you had that were similarly long or at least really long. Uh, if you try to figure out what's a reason for change and why, like, and where and how you should be separating those classifiers, it's not necessarily an easy answer, especially with some more complex business logic. But the reason for change really comes from people. And that's what Uncle Bob said. And he was also thinking about it a long time, several years to really come up with a good answer. And what he said is that it comes from a single person or a group of people. So when we think about the page object responsibilities, let's give it a couple of seconds, 10, 20 seconds. And please think about who are the responsible people or groups of people for a change in the locators, in the elements, in the actions, and in the user flows. So I will give you a little bit of time to think about it. Okay, so and I'm going to show you now what I think, and I'm very happy to see if anybody thinks the same way or or very differently. So I'm very happy to debate that. But in my opinion, the reason for change for the locators and elements come from the developers, because they are the ones who build the applications or product that we are going to test, right? So if they implement it in a different way or with a different tech stack, that's definitely going to have an effect on how the locators and elements look like and whether they are changed or not. So regarding the actions and user flows, now that's, I think, debatable, and it also depends on the organization that you're working in. But basically, I think that the reason for change comes from either the business or the tester or testers. And but in my opinion, ultimately, if everything is done correctly, then the reason for change should come from testers because they are the ones who create the test scripts, right? Still, business might affect it, obviously. So that means that that the single responsibility is broken by the page object pattern because there are at least two reasons for change in a page model. Okay, so the other issues that were brought up by other people that I have talked with, and like I read, of course, a lot of articles about it. Like I made my research on what people think about the page object pattern. Some say that it breaks the open close principle. I don't agree or don't fully agree. Some say that it breaks the Yagni principle, which is you're never going to need it. Or you're not going to need it. And I think that's not true. And the reason is, like pointing back to what I said previously, is that it's all up to you, like how you implement the page object. And I mentioned that you should create page models for those pages that you're going to interact with. And you should be storing the locators and elements and the actions of elements that you're going to interact with in your test cases. Why would you make additional work for yourself and and list all the elements and their locators in your class files when you're not going to interact with all of them? So I think that's more up to the person, and it's not because of the page object. The page factory is also not recommended anymore. There's a keynote speech by Simon Stewart from a couple of years ago, I think from 2014 or 15. I can't recall the exact year, but yeah, it's on YouTube, so you can find it easily. Okay, all right. So that said, we have approached the flow model pattern, and first I'm going to talk about how you can leverage it in UI test automation, because the page object is meant for UI test automation. So I want to really show the parallels between the two, how you can leverage the two at the same time in the same project. Later on, I'm going to talk about other ways to leverage flow model. Let's first think about UIs. Okay, so you heard about these issues with the page object. How can you fix it? So if you think about the page object as a house, and which has a facade, like just like a facade pattern, this facade is going to hide the pages and its widgets, other widgets, and user actions, user flows, all the details, locators and elements. So everything is going to be at the same place. Now with the flow model pattern, it's going to look more like a double faceted house, big facade, and there's this cute little two or a couple of different smaller facades, maybe above the windows. And so how it looks like, you have the pages and the widgets, the page models, and the flow models are going to be above those pages. So they are going to really hide the details, not just for the user actions and the user flows, but completely for the pages and widgets. The test cases are not going to be aware of at all of where you are, what item you're going to be interacting with. They, of course, everything is behind the scene. Okay, so the UML diagrams, I think they are pretty useful to at least know about them, even if you're not leveraging them in your project. And for me, I always liked the UML state machine diagram. Maybe that also was one of the reasons I came up with the flow model. And for me, the flow model pattern is basically, it's kind of like a UML state machine diagram. If you think about it, let me just give you this example of a successful login scenario. You already saw a linear scripting version of that. Let's see state machine diagram of that example. So, okay, so there's this main page over here. You click on the sign in button, the login page appears. You are going to write all your credentials in. You click on the login button, the profile page appears. You can do whatever you want there. You click the logout button and you're back to the main page. So these are your states here, these blue ones here, and all the arrows are showing the transition. And this is exactly what the flow model is about. You have your main page over here. You click on the sign in button. You get to the login page. You type in your credentials. You click the login button. You're on the profile page. Maybe you want to edit your profile. You're still going to stay on in the same state on the same page. Once you click the logout button, that's when you transition to another state, to another page. So for me, how it looks like is basically your states are going to be your page models. The transitions are going to be your flow models. That's what you are modeling in the flow models. And that's the difference between the page model pattern and the flow model pattern, is that in the page model pattern, or the page object pattern, to be more precise, you're going to store everything in the same class file. So not just the states, but the transitions as well. In the flow model pattern, these concerns are separated. And because of that, the single responsibility is not broken anymore. Okay. So how can you leverage this in a project? Like we heard about the theoretical background. I want to give you some more details on how you can implement it in your project. So let's go with a trial concept here, and where you have a business logic layer with all the app specific libraries. So what you would have, of course, some app-specific base test is necessary, maybe base page as well, any other libraries and configurations that you might have for that application. But that's also where you're going to store your flow models and page models as well. And the test scripts are just going to directly communicate with the flow models, not with the page models. That's how it looks like. All right. So, and the example is going to be built on this previously shown trial concept. So let's say that you have a base page, a generic base page in your core layer, and user actions that are going to be basically the base user actions for the login flows. And all the pages and widgets are going to be built on top of the base page. You might even have an app-specific base page here if necessary, but in this example, I'm not going with that. And of course, there's one scenario here that I'm leveraging for showing you this example with codes. Okay, so this is a set of lines, coded lines that I have shown you before, a linear scripting approach. And obviously, this is not maintainable in the long run and not reusable. So the copy paste pattern is not how you should be doing it. And so there are no page models here, nor flow models. Okay, let's fix that. So first, I'm showing you how I'm leveraging the page models, fixing it. So I'm creating a very simple login page here. This is an Android example. So there, the IDs are the resource IDs. So this is what this RID means, which is generated, typically generated by Android itself. And so what happens, you identify username, login button, password, show password, and many other items. The views are basically the same as web elements, but this is an Android example. That's why I have it as view here. Okay, so if you go onwards, then the next step that you have to make is once you have your elements defined in your page models, now you have to use them in your test case. So what I'm doing here is I'm calling these click actions on these elements. And now it's perfectly clear for me where I am. So if you think again about the state machine diagram, I have my states defined here. I know in each of the steps which state I'm at right now, which element I am interacting with. So that's already really great. It's a huge step forward, and it helps with maintenance really a lot. Okay, but our work is not done here. So next up, of course, you have to define flow models as well. In this example, there's only one flow model. Typically, you would leverage multiple different flow models. Here I'm just going with a very simple example. Okay, so first up, there's this login flow, open login page, type username, and all these actions, and some of them like single atomic actions, some of them are more complex scenarios, are concatenated here. And what happens is that that you're referencing to those web elements that are in these different page models, like menu, which is a widget, login page, which is a page, and so on, home page. You're hiding those information from the test cases. So in the test cases, you're not going to see anymore where you are at, but you're going to see what you're doing exactly and what is the flow that you're going through, which is, I think, closer to the mindset of a tester, at least when I was testing that first application where I came up with the flow model. It was much easier for me to follow this concept. And what happens here? So now your login test case has these login flow elements here. Open the sign menu, then opening the login screen, typing your username, password, then you finish your login. So basically you click on the login button, wait for the for the home screen to open up, you validate whether the actual login happened, and then you open the sign menu and you log out. That's it. And you can already see here that it's a much shorter script, even compared to the one that is leveraging the page models. And it's also very easy to quickly analyze it and realize it what this test case is about exactly. What are the exact test steps? So to compare them, on the right side, of course, you can see the linear script. It's much longer and it's not really easy to read it. Still not super bad, but it's not still not so easy to read it quickly. The one with the page model is already much more readable, or the is maintainable. But if you want to reuse some of the steps, some of the concatenated user flows, such as a successful login scenario, which you might leverage in a couple hundreds of test cases, then the flow model is definitely going to make your life easier. It's going to shorter your test cases and make it more readable. That's my opinion, but I'm really open to hear and read about your opinions as well. So please write it in the chat and let me and let everyone know what you think, and whether it's also in your opinion more easily used or not. Okay, so that's how these different scripting are comparing to each other. And let me go to the next topic, which is about the end-to-end adaptation. So what does that exactly mean? So it means that, and I'm coming with one example of a test pyramid. Of course, there are hundreds of different kind of test pyramids. I don't want to go into that topic because I could talk about that for another hour. So let me give you just one example where you have a UI level, API level, contract level, which is more of an integration level, and component level where you could actually leverage UI and API testing as well, but not against real services and real data, but without data, and of course unit testing. Okay, so for me, in my opinion, again, end-to-end testing is there are many ways people describe it, but what I want to show is more on these two upper levels, where you can of course go with still with atomic test cases, but it makes more sense to have some more complex scenarios going through the through some pages or systems and validating how that system behaves. And if you want to do that, like you're not going to just leverage UI testing anymore, or maybe you're only just validating the API responses. In that case, you're not going to have a page model, a set of page models anymore, but you're going to have utility classes if you're thinking about just API testing. And this is the example that I'm bringing here. So I'm going to show you how the flow model can help you in end-to-end API testing. It's very important, not something that you're not going to leverage in atomic test cases, but only in end-to-end scenarios. Okay, here's the example. And so let's say that you are an account holder and you have a bank card and you want to validate, like you want to make a transaction, but your card gets suspended. Then you call the service center and you try to get your card unsuspended. It gets unsuspended. Then you try to make that transaction again. And this time it should be a successful transaction. So this is the scenario that I'm going to automate the testing for. And this is how it looks like with leveraging the flow model. So what happens, I have an account flow, and one of the steps that I can do there is log in with the active with an active user and with a valid card. And then after that, I would like to suspend the card, validate the suspension, and make a valid transaction. Now, it's very important, even though my card is suspended, the transaction itself is valid, but it just not going to be successful. So I validate whether this transaction under suspension was unsuccessful. So if it's unsuccessful, that's great. I go on and I unsuspend the card. Then I validate the unsuspension and make that valid transaction again, the same transaction. It's going to be the same call. This time it should be a valid, not just a valid, but also a successful transaction. And I need to see the changes in the balance. And of course, I want to make some validations in logs, such as leveraging like Splunk or also validating database transactions. Okay, so you could see that if you read through this, it's very easy to understand the whole test case and what's the business logic, or what's the business value that we are bringing with this test case. But actually, there are more steps within some of these methods. And for example, when you validate the suspension, you want to validate the response code and the party itself. You want to validate the database, whether the suspension happened there or not. And in this example, I'm using Splunk, but you could use other tools for validating the logs and collecting the logs and rating the logs. So that's also very important, whether everything is generated in the logs or not. If not, then obviously that's not good when you want to find issues pre-production and also in production as well. Okay, so here, so this example, you could see that the flow model can be leveraged not just for like simple flows where you would only use, let's say, just the login flow, but you can mix multiple flow models as well. And this way you can create more complex test cases as well. Okay, as a summary and conclusion, the flow model abides to the single responsibility. This way it fixes, I think, the major concern with the page model, page object pattern, and it's basically enhancing the page object model by that, and also enhances it with introducing a dual facade approach. So instead of only having one facade over the pages, now you have a facade over the actions that you're going to do. So that's more of a tester's mindset and more following testers' best practices. It also provides a higher abstraction, obviously, with the, with the dual facades, which further improves maintainability and readability of the code. And my experience is that whenever I started on a project, introduced the flow model, and I had to teach it to other people, it was always easier to do the ramp up in knowledge transfer. One example from 2014, at the end of 2014, I had to do the test automation of 3 different mobile applications, 2 Android and 1 iOS, and it was, of course, a lot of work for me to cover all the test case development. And what happened, we brought in 3 junior developers. All of them were super new, fresh from our junior junior development program, 3-month program. And so because they were juniors, they still had to get some project experience. So what we did, that 3 of them were able to start right away doing test automation. Obviously, that's not application development, but it was already great for them because they could get some project experience, learn more about Scrum as well, how to work in teams. And they were able to start being productive already on the second day, because on the first day I gave them a knowledge transfer and like an overview of how we do test automation project. Of course, it was helpful that I already give them some knowledge transfer, not knowledge transfer, but a one-day course on test automation during that program. So if we count that, then it's basically 2 days of efforts to teach them. And then on the third day, they were able to be productive, write test cases, write flow models and page models as well. So I think that's a pretty neat aspect of the flow model and of course the page model as well. Okay, and compared to the page model, flow model can be leveraged not just in UI testing. So I think that's pretty useful for a couple of my projects where I was focusing more on API testing or combining UI and API testing. It was pretty useful. Okay, of course, it's not necessarily easy to design flow models, especially if you don't have a tester background. I think it's going to be tough, but in that case, you can ask one of your testers in your project to help you and sit together and figure out which flow models you could define and leverage in your project. Okay, that said, I hope you liked the presentation and I hope that you were able to learn something new today and something that you'll be able to leverage in your project, either in this very project that you're working on right now or in a future project if that makes more sense. And again, thank you very much for listening to me. And if you have any questions, just shoot it in the chat. I'm here and I'm going to see that I still have 17 more minutes. So I'm very happy to answer all your questions. And I also would like to thank Developers Shore for organizing this session. And I'm happy that you're spreading the word about testing and test automation and anything related to software engineering. Okay, questions. Let me see if anything was posted in the chat. Yeah, I see one thing in the chat. I want to ask about Cypress. Is it fit for big projects? Okay, all right. Let me try to give you an answer. This is not necessarily related to flow model, but let me give you an answer to that. In my opinion, so at EPAM, let me slow down. So at EPAM, we are kind of tool agnostic. What does that mean? That means that for us, it's not necessarily the tool that really drives us. We are not tied to one tool, but we have knowledge of many different tools, test automation tools, and other tools as well. So my mentality is that it's not the tool that's most important, but more the practices, such as leveraging design patterns and a proper architecture. Now the question is Cypress the right tool for you in your project? If for example, you already have an experience in Cypress, or maybe you don't have an experience in it, but all the other colleagues that you are working with have experience in, you have, okay. So if you have experience in Cypress and you like it and it's convenient for you to use Cypress, and if you believe you can easily teach it to others or your other colleagues who are going to do test automation as well, already know Cypress, then I think it makes sense to use it. It doesn't matter if the project is small or big, because ultimately I think what matters is how you design your test automation solution and the framework within that solution. How do you integrate to CI/CD pipelines? That's not up to Cypress, of course. Like maybe it's easier with Selenium to like run on servers and build a grid. Maybe then in that case, it makes more sense to leverage Selenium. But if you have experience in building something similar with Cypress, I think it will work. If not, then you can do a pilot project and see whether you can implement it successfully for a bigger project. If it works, then go with it. If it does not, then you can still switch to another tool. Sure. I'm very happy that I was able to have. Thank you very much. And yeah, again, thanks everyone for joining. If you have any questions, shoot me a message on LinkedIn. You can find some of my articles and blog posts, peterföldházi.com. So go ahead and read those. Thanks again and have a lovely day.